Good evening, everyone. So for today's adventure, what we're going to be doing is we're going to be going over a chapter 15 concept using equation constants and actually the ice table, initial change in equilibrium, to find concentrations at equilibrium. And this problem is where we're going to have to actually use the quadratic formula, right? We're all having flashbacks now. So the problem that's given to us is they give us an equilibrium reaction, and it says the K sub C, the equilibrium constant for the reaction, is 7.0. So they say what happens when you mix 0.25 moles of Br2 and 0.55 moles of Cl2 in a 3-liter container. What's the concentration of Br2 and Cl2 and BrCl at equilibrium? So remember, in an ice table, you should put concentrations. So if we divide 0.25 by 3, we get, I worked all this out a second ago, we get 0.08333 molarity. And if we put 0.55 moles per 3 liters, we're going to get a molarity of 0.18333. Okay, so these are the numbers that we should plug into our ice table. So let's go ahead and make that. So remember, on the left you go initial change in equilibrium, and I like to write the reaction at the top. So Br2 is being added to Cl2, and it's making an equilibrium with BrCl2, or BrCl, sorry, my bad, BrCl. So initial concentration, so as far as the problem goes, we initially add 0.0833 of Br2. I'm going to put the other 3 there because that's what I did with all my math. For Cl2, we added 0.18333, right? I'm trying to keep this a little organized. And the problem doesn't indicate that any BrCl is actually made just yet, right? So 0 initially. So the change, for Le Chatelier's principle, right, there's nothing over here, so things are going to shift this way, right? They're going to go to the right. So what I did was a huge no-no. I forgot to put the 2 in front of the 2Br. So the change is going to be plus 2x, right? Because 2 BrCls are going to be formed according to the equation. Now, the change, remember, you put the coefficient of the, and that's the number of x's. So we're going to lose 1 Br, and we're going to lose 1 Cl. We're going to gain 2 x's. So then we total this up for the equilibrium, total this up for the equilibrium, and total this up for the equilibrium. So at equilibrium, I'm expecting 0.08333 minus x for Br2. I'm expecting 0.18333 minus x for Cl2. And I'm expecting 2x for 2 BrCls. Right? So let's go ahead and, on a brand new sheet of paper, let's set up our K sub C equation. So K sub C is going to equal, right, and since it's 2 BrCls, it's going to be the concentration of BrCl squared divided by the concentration of Br2 times Cl2. So that's all I did there. So now I'm going to plug in the actual numbers that I have, and I'm starting way over here because I have a feeling that it's going to take up a lot of room. So the concentration of BrCl is going to be 2x at equilibrium. So it's going to be 2x squared. The bottom here, though, is going to be a little bit longer. Br2, we said it's going to be that 0.08333 minus x. And Cl, if you recall, was 0.18333 minus x. Woo! Right? So we're going to get to work solving for x, because that's going to be our change. And if you guys are flashing back to algebra, totally normal, totally natural. So 2x squared is really 4x squared. Just taking things and making them pretty slowly and slowly. So this is where you have to FOIL. If you guys don't remember that, really practice. You have to do the first, the outside, the inside, and the last. So if you multiply these firsts, you're going to get 0.01527. This is going to be 0.18333 minus x. This is going to give us 0.08333 minus x. If you combine those two, you're going to get negative 0.2666x. And then last, just minus x squared times minus x squared is just plus x squared. And all this is equal to 7.0. So then in order to get this from the bottom, you have to multiply everything by 7. So 7.0 times this is 0.10694, and 0.2666 times 7, we're going to get a negative 1.8662x. And then x squared times 7 is just 7x squared. And all that is equal to 4x squared. So if we remember back in the day when we were using our quadratic formula, you have to get this side to equal 0. It needs to equal 0. So in order to do that, we're going to have to minus 4x squared. So it's going to be 0.10694 minus 1.8662x plus 3x squared equals 0. Now we can plug this into a quadratic formula. So I would not be mad if you guys had a calculator on the side for this. I don't expect, this takes a very long time, and unfortunately, you know, it's part of this chapter. So if you do have a calculator that you are able to plug in A, B, and C, because this is our A, if you guys recall, this is our B, and this is our C. If you have a link for that in your phone, or a calculator that can do that, because I know the TI-83 pluses and then on can do it, that is acceptable for me. This is not a math class per se. It uses math, but it's not teaching math. So we have two options for x. X is going to either be 1.260, or x is going to be 0.0283. Now here's the deal. What was our initial concentrations? Our initial concentrations were as low as 0.08333. Is it possible to subtract a whole 1.26 from this? Absolutely not. So it can't be this answer. So when you do your quadratic, you'll either come up with an answer that's way too big and one that makes sense, or one that's negative and one that makes sense. So clearly pick the one that makes sense. So this must be my x. So we could even look right here. So my concentration for BrCl is equal to 2 times x. So 2 times this, and I did not calculate that out, so 2 times 0.0283. My concentration of BrCl is going to be 0.0566 molarity. Concentration of Br is going to be 0.0833 minus x, which is equal to 0.0283, 0.05503. And my concentration of Cl2 is going to be 0.18333 minus X, and that is 0.15503. So we'll say 0.155 molarity. So here are our answers. I know it's an awful lot of work. I know it. I know it's an awful lot of work. But these are probably the trickiest things we might be doing in this class, to be honest. So, to recap, we were given an amount and a volume, so we turned it into a concentration. We set up our ice table. We were given reactants, and it said there were no products in that container to begin with. So, initial is the concentrations we found, and there was no products, minus the coefficients. So minus 1 of the BRs, minus 1 of the CLs, and we're forming 2 BRCLs because that is the coefficient in the equilibrium reaction. So then we end up just totaling those up. We plug that into the K sub C equation that we can actually, the K sub C reaction, the equilibrium ratio that we can actually come up with. BRCL is squared because there's a 2 in front of it. So then we plug in the terms that include X into it. And then we FOIL. We go into a flashback of math. And then we use the computer because I'm not going to do the quadratic formula on this. That just takes forever. We plugged in our A term, our B term, and our C term, and we found out that there were 2 options. There's no such way that we could be subtracting 1.26 molarity since our initial concentrations were so small. So only the second answer made sense. So then we just went ahead and plugged those into our equilibrium concentrations, and we found our concentrations. So I know this is a bit to take in, but practice is really going to be the only way that you can do these things pretty confidently. So good luck!